Hello everyone, this is Venkat and I have my colleague Ron with me for this talk. Today we are going to present our talk titled Best Practices for Enabling Speculative Execution on Large-Scale Platforms. All right, let's take a look at the agenda. Today's agenda will start with background and motivation, talking about some of the issues with enabling speculative execution on a large-scale platform. Then we discuss about the enhancements we made to Spark Engine with respect to speculative execution. Config tuning that's required with speculative execution. In the second half of the talk, Ram would talk about speculation metrics and the analysis done before and after enabling speculative execution with a case study. Then we will share some of the learnings we got in the process of enabling speculative execution with user guidance, and finally concluding with the future work and summary. Okay, let's quickly do a quick primer on speculative execution for those of us who are not aware of speculative execution within Spark. Spark achieves parallelism by running tasks in parallel as part of a stage. Within a stage, when there are tasks which run significantly slower than the other similar tasks, Spark launches a duplicative execution of the task on a different host as part of speculative execution. Between the two instances of the same task executions, whichever one succeeds first, that will be used for the result, and the other one is kill. This can be further confirmed by checking the stage tab in Spark event. Now that we talked about speculative execution, let's quickly look at some of the tuning knobs available for tuning. Spark speculation config is used to enable or disable speculative execution of a Spark application. Spark speculation interval config determines the frequency at which to check tasks for speculation. Next two configs are the key configs for speculative execution: Spark speculation multiplier and Spark speculation quantile. Spark speculation multiplier tunes the aggressiveness of speculative execution within a stage. How many times a task is slower than a median in order to be considered for speculation. Spark speculation quantile determines the fraction of tasks that must be completed before speculation would kick in for a stage. Let us now look at the motivation of the talk. Although speculative execution speeds up straggler tasks but adds additional overhead, so there is a need to strike a balance between the two. Spark speculative execution default configs are generally aggressive, especially for batch apps. Also, speculating tasks which run for few seconds can be wasteful. So in order to avoid these, we also need to investigate impact of data queues, overloaded shuffle services in the context of speculation. Also, impact of enabling speculative execution by default in a multi-tenant large-scale cluster needs to be thoroughly studied. Now that we have seen the motivation for the talk, let us see some of the improvements we have done to Spark itself in the context of speculative execution. Tasks run for few seconds, getting speculated waste resources unnecessarily. In order to prevent the tasks that run for few seconds getting speculated, we internally introduced a new Spark config, Spark speculation min runtime threshold, to prevent tasks from getting speculated before running for min threshold time. Currently, this is set to 30 seconds in our environment based on our experiments. Also, similar changes added in Apache Spark later as part of Spark 33741 Jira. Currently, there are no metrics available for speculative execution from Spark QA. Without enough metrics, it is hard to understand the overall outcome of speculative execution itself. In order to understand usefulness as well as overhead, additional metrics for speculative execution is added by enriching the existing app status listener specifically at the task start and end events. Okay, now that we see we need additional metrics with respect to speculative execution, let us see what are the additional metrics we have added for speculative execution here. So similar to the regular stage level metrics, we have added metrics for speculative execution as well. So some of the metrics are total number of speculated tasks for a stage, number of successful speculated tasks for the stage, number of killed and failed speculated tasks for the stage. Okay, now with the newly added metrics, we can get a speculation summary for each stage under the stage tab as part of Spark UI, which we can see from this screenshot. These metrics helps in further tuning the configs whenever needed. Okay, unfortunately, the default speculation parameters were often too aggressive and wasteful. LinkedIn Spark jobs are mainly offline batch jobs, which means the speculation parameters can be on the conservative side. Let us see the tuned speculation parameters for LinkedIn's platform. So in our platform, we have set Spark speculation multiplier to 4 compared to the OSS 1.5. From our experiments, having speculation multiplier set to 1.5 often leading to premature speculation, leading to wasted resources. Also, we have set Spark speculation quantile to 0.9 compared to OSS 0.75. This is needed because it's the last 10% of the tasks which require speculation, which are taking longer than the other set of tasks. Also, Spark speculation min threshold is set to 30 seconds, as we have seen previously, meaning that tasks that run for less than 30 seconds won't get speculated. So now that our min threshold is set to 30 seconds, we can also relax our Spark speculation interval to 1 second, as we are not speculating tasks that runs at least for 30 seconds. Now Ron would further take you through the analysis of the metrics as part of the case study, as well as at the platform level. Over to you, Ron.
Thank you, Venkat. Now I am going to show you the speculation metrics data we collected. I will also share with you our performance analysis. We care about ROI, return on investment. We want to know the degree of the return or the performance gain. For a given performance gain, we also want to know the degree of investment or the additional overhead. And we measure various metrics for 1 week on a very large cluster with more than 10,000 machines. Basically, our environment is a multi-tenant environment with more than 40,000 Spark applications running daily. And we enable dynamic allocations. And with resource sharing and contention, the job performance varies due to some transient delays or congestions. Now let's look at statistics at task level. And for 1 week period, and we look at the ratio of all the launch speculation tasks over all the tasks. By the way, as Venkat mentioned earlier, we set speculation mean threshold to 30 seconds. So we will consider those tasks with duration greater than 30 seconds for speculation. And then now let's look at the duration. The ratio of duration of all speculation tasks over duration of all the regular tasks is just a small percentage. It is 0.32%. And also for 1 week period, we launched a total of 2.73 million speculation tasks. And now I want to introduce this concept of full for speculation task. A speculation task is full for if it can finish earlier than the corresponding regular task. And here we found out that if we divide the total number of full for tasks over all the speculation tasks launched, we get 60%. Yes, the success rate at 60% is kind of high. This is because we set conservative values in our configuration parameters. Now, let's look at statistics at the stage level. So here, we only consider those stages that are with duration greater than 30 seconds, and also with at least 10 tasks in a stage. We call this stage as eligible stages. And among all the eligible stages, 41% of them have launched speculation tasks. And among those stages that have launched speculation tasks, 76% of them receive some performance benefit. It means that they have launched they have got some fruitful task. Let's look at the statistics at application level. In 1 week, we had a total of 157 Spark applications, and 38% of all the Spark applications launched a speculation task, and 87% of them benefit from the speculative execution. It means that those applications have at least one fruitful or a speculation task. Overall, 32% of all Spark applications benefit from the speculation and execution. In our multi-tenant environment, we have many in production jobs, and also we have many development jobs running on our very large cluster. So the jobs varies daily. And here we just sample a mission critical application, and this application has been run every day. It has a total of 29 Spark application flow. Some Spark flow run daily, some Spark flows run hourly, and each flow has a well-defined SLA, service level agreement. And we took measures of all the flows for 2 weeks before and 2 weeks after we enabled speculation. Here in this diagram, we can see the job elapsed time both before and after enabling speculation. And in order to give the equal weight to each job flow, we compute the geometric mean of all the job elapsed time for all the flow. And we found out that after we enabling speculation, we were able to reduce job elapsed time by 13%. We also computed the geometric mean of the standard deviation of all the job elapsed time, and we found out that after enabling speculation, we were able to reduce the standard deviation of the job elapsed time by 41%. The 41% reduction in the standard deviation is significant. This is because before we enable in speculation feature, all the job used to run with a big range of the job elapsed time. So many of them did not meet SLA, service level agreement. And after we enable in speculation, we are able to reduce, are able to reduce the variation of the job elapsed time, so that they can all finish within a narrow range, so that they can meet SLA. We also look at the total resource consumption in gigabyte hours. Here, the gigabyte are the memories consumed. As for the hours, it is the CPU the duration in hours. And the gigabyte hours are a measure of the combined CPU and the memory resource consumption. And we use this formula. First, driver memory in gigabytes times app duration in hours. This is the total driver resource consumption. As for the executor resource consumption, we use executor runtime, which is task elapsed time. We basically add all the task elapsed time for all the tasks within a stage. We add them together, and then we add all the numbers for all the stages together, and then times the executor memory in gigabytes. Then we can get the total executor resource consumption. We found out that after we enabled in the speculation, we were able to decrease the total resource consumption by 24%. Now, we want to discuss under what situation speculation can help. The first case is, a mapper task is slow because the running executor is too busy, or there's some system hang due to hardware or software issues. Before we enable in speculation, we used to see runaway tasks sometimes due to some system hang. Basically, we see the system hang when after a Spark driver has launched a task, but Spark driver has been waiting for a long time without any response. We call this as a runaway task. After enabling speculation, we rarely see runaway tasks. This is because the runaway tasks were later killed since their corresponding speculation task can finish it earlier. There is also another case. The network route is congested somewhere. When we launch speculation task, and this speculation task may take a different network route. Also, in terms of data locality, the regular task normally will reach load local or rec local copy, and the speculation task usually reaches the ending data copy. If the initial task was not launched in an optimal way, its speculation task can have a better locality. Also, there are some situations where speculation cannot help. The first one is a data skew. When a data skew exists, even we launch a speculation task using different data copy, however, data skew still exists. So speculation cannot help the data skew case. The second case is the overload of shuffle services, which has caused reducer task delay. Because the shuffle service is shared by all the executors within the same node, and also there is only one shuffle data copy. So the speculation cannot help this case either. Also, there's the third case. There's not enough memory, and it has caused task to have a disk spill. Basically, Spark driver does not know the root cause why a task is slow. It does not have it does not know the current condition of all the components of a cluster system. It will launch a speculation task based on the configuration parameters values we set. Now we want to summarize our talk. At LinkedIn, we further enhanced Spark engine to monitor speculation metrics. And also in this talk, we have shared our configuration settings to manage the speculation execution. I would say that depending on your performance goal, you need to decide how much overhead you can tolerate. Then you can set your configuration parameters accordingly. I want to point out that, if your workload is like LinkedIn's workload, which is mainly batch, offline, and jobs, then you can use our configuration parameters setting as a reference. In terms of ROI, if speculation parameters are properly set, there are a couple of investment or overhead. There are also some returns. The first investment, there is a small increase in network messages. Second investment, there is a small overhead in Spark driver. Also, there are some returns. The first return is a good saving in the executor resources. The second return is a good reduction in the job elapsed time. The third return is you can get significant reduction in the variation of the job elapsed time. You can have better predictable and more consistent job performance. In terms of our future work, we will investigate in adding intelligence to Spark driver in order to decide whether or not to launch the speculation task. As I mentioned, there are cases, there are situations speculation task can help. There are also some cases speculation task cannot help. We need to distinguish between these two cases. If we can know the condition of all the components of a cluster system, this can help us distinguish which case we have. Also today, many people run Apache Spark on the cloud. On the cloud, we have unlimited resources. However, we need to factor in the monthly cost. What is the cost in launching additional executors? Finally, we want to thank Eric Boschweiler, Sunisa Biren, and all the members in LinkedIn's Spark team for their enlightening discussions and their insightful comments. So this is the end of our presentation. We welcome your feedback. Thank you.